Taking a look at question 9903, it says refer to figure 1.3. Given the following conditions, what is the takeoff distance over a 50-foot obstacle? The following conditions are listed below. You have your pressure altitude at 6,000 feet, outside air temperature 35 degrees Celsius, weight at 14,500 pounds, wind component is 10 knots of headwind, and your ice veins are retracted. So we know, or we want to point out what we're looking for here. We want the takeoff distance. So that's the answer that we're looking for. And then, as always, let's take a look at our chart and figure out exactly what information we need. So we need an outside air temperature. We need some kind of pressure altitude. We need a weight, wind component, obstacle, and then that'll give us our takeoff distance in feet. And as always, we're going to follow our example down below with our own information. So we're going to start by entering the chart at 35 degrees Celsius. So let's come in here and make a little mark at 35 degrees Celsius right here. And we're going to take that up to the pressure altitude, which is 6,000 feet. So we're just going to take that up to the 6,000 feet line, which is like that. So let's go ahead and just make a straight line up to meet that pressure altitude. And then we're going to go ahead and draw that over to the reference line. And remember, if it helps you, you can always go ahead and highlight or mark where those reference lines are. And remember that we're treating those as though they are stop signs. So we're just going to highlight all three reference lines right here. And those are our stop signs. Once we're at this new reference line, we're going to go ahead and now account for our weight, and that was 14,500 pounds right here. So I like to draw a reference line, and I'm going to draw that at 14,500 pounds. So zooming in, we can kind of see here's 16,000, this is probably 15,000, and then 14,000. So 14,500 should be right about there, I would say. And I'm going to draw a straight line directly up as my reference line. And then I'm just taking my red line here and I'm dragging it down to meet this reference line that I've created. And I'm trying to follow as close as possible to the chart's angle as I can. Then I'm taking that reference line straight over across to my next line here. Now I'm accounting for headwind or tailwind. It says that my wind component is 10 knots of headwind. So yet again, I'm just going to go ahead and draw myself my own reference line here at 10 knots. And for a headwind, I'm going to bring that line down. So I'm going to follow the layer of the chart or the outline of the chart. If I did have a tailwind, note that I would go up from this point. Like if I had a 10 knot headwind, my line would look like that green line. And then I'm taking that straight over again just to here. Now for this one, we're only considering that we have a 50-foot obstacle. You're never going to have an obstacle that's anywhere between 0 and 50. You're always just accounting for 50. So now I'm actually going to just follow this line right on up because I do have a 50-foot obstacle. And that's going to take me right about here. I'm actually following almost exactly to the line on the graph. We can see that we're at 4,000. This is probably 4,500 and then 5,000. So I'm going to say, without looking at my answers, that I'm somewhere around maybe 4,200-ish. And then as we come and look over at our answers, we know that the correct answer is 4,150. And as always, you can mark your answer choices on the other side of the graph if you're confused. So 4,550 would be right about here. And our other answer, 2,600, would be maybe here. So you can see that the closest answer you have is that 4,150 feet.